Alright, let's see. We got medium, greatest sum divisible by 3. Feeling pretty good today, so I think I should be able to do this. Given an integer array nums, return the maximum possible sum of elements of the array such that it's divisible by 3. Maximum possible sum of elements in the array. Okay, so 3, 6, 5, 1, 8. So 8, 8, 6, 5. Well, it's either going to include 1 or maybe not include 1, so let's add them up. This is 9, 13, 14. So I think it might be 9 plus 9. No. Yeah, I guess it is 9 plus 9. Okay. 1, 2, 3, 4, 4. Adds up to 14, so you can maybe subtract 2 and get 12. Interesting. Alright, this doesn't seem very hard. To be honest, this might be closer to easy than some of the mediums. This is between easy and medium, I think. So basically numbers is going to end up in 3 buckets based on the remainder. These are all positive. So I don't have to worry about negatives. So they end up in 3 buckets based on the remainder. And I think what you would do would be you take the sum of all the elements. That'll be your maximum. If it's divisible by 3, then obviously return that. And then you would subtract the smallest from the bucket that would have the remainder that you need, I think. Subtract the smallest from the bucket of the remainder that you need. So I'm pretty sure it's guaranteed. That's not necessarily true. Either subtract. So there's a few combinations. So let's say my sum was, the sum is something that has a remainder of 1, for instance. So for example, 100. So in theory, if you had a 1 in your list of numbers, then you would use that. Or something that has a remainder of 1 that's small, like 4 or 7, because the equivalent would get you to divisible by 1. But let's say your smallest bucket that has a remainder of 1 is actually like 10. But then you have something that has a remainder of 2 that is, what's an example? 5 and 5 is actually going to be the same. So let's say your smallest remainder of 1 is actually like 31. But you have remainder of 2's that are 5 and 5. So in theory, you want to use either the smallest remainder 1 or the smallest 2 remainder 2. Don't want to use remainder 3 because, or remainder 0, because that just gives you the same spot. Alternatively, if you have something that has a remainder of 2, so 101, then I think it's going to be the reverse. Either you could say you subtract the 2 smallest things that have remainder 1, like 2 1s, or you subtract the things that have the smallest remainder 2, which is like 5. Yeah, so I think those are the only cases that you have to really worry about. I think anything else just reduces to that. So I think maybe I can try all the values and then just see what I get. Keeping track of the smallest two of a certain bucket, where the buckets are remainder values, is going to be a little annoying. Guess I could add it to a heap of 2 and yeah. Okay, keep tracking the smallest 2. Guess I could maybe even sort it. Sorting it's probably first though. Let's say max possible. Max possible is equal to the sum of the numbers. I'm not sure if this is faster than actually also using a statement inside of for that iterates over all the indices. Might be faster, might be slower. Anyways, I guess I need to first determine if it has remainder 1 or remainder 2. So if it has remainder 1, then find the things that are remainder 1, the lowest remainder 1 and the 2 lowest remainder 2s. So if I guess I can do this trivial case. Sum is already divisible by 3. So if max possible, the remainder of that divided by 3 is 0, return. Okay, so let's go if max possible is divisible or has a remainder of 1. So yeah, find the low remainder 1 is going to be infinity. Low remainder 2 A and low remainder 2, I guess. I don't know if yeah, the remainder 2B are both also infinities. I guess I can just declare them in one statement. So for every value in nums, if the remainder of the value divided by 3 is 1, then if this is smaller than the stored lower remainder 1, then low remainder 1 is equal to this value. Else, if this value mod 3 is equal to 2, then I wonder if I should do this switch statement. Given my search history, I guess I've done this before. Is this any faster? Match case. Is match case faster than if else in Python? Probably searched for this before as well. Simple equality checks against a few distinct values match case often show very similar performances. Yeah, I guess maybe match case is probably going to look a little better since that only does the operation once. So it's going to be match colon new line indent case colon new line indent match parentheses or no parentheses? No parentheses. Match value mod 3 case 1 low R1 equals value case 2 whoops, this should be an if statement. Value is less than low R1 equals value, and this also needs to be an if statement here. So I need to store the lowest two. So I think I need to check to see if it's smaller than the bigger. If it's smaller than low remainder 2b, value is smaller than low 2 remainder 2b, then first check if it's smaller than low remainder 2a. They're smaller than both stored. I guess I could also do like a I'm not sure what I'm thinking. I'll use less than low remainder 2a, then low remainder 2a, and low remainder 2b is equal to the value, comma, low remainder 2a. So slot this in at the smallest. Else low remainder 2a. I guess I could do this in a single statement. I want to use the kind of tertiary command, or not tertiary command, kind of question mark colon syntax. So I think I can do low remainder 2a. Actually, has to be still nested here. Low remainder 2a, low remainder 2b is equal to value comma low remainder 2a if value is smaller than low remainder 2a, else it should stay the same but change the second one to value. Okay, yeah. So if this is smaller than the second smallest, then check if it's smaller than the smallest. Smaller than the smallest, then this replaces the smallest, and current smallest replaces the second smallest. Otherwise, this just replaces the second smallest, but not the smallest. And I think that's it. For that case. And then the final case is going to be for the remainder. What happens if there's not two of them? Actually, I guess this should probably have a return. So if it's still infinity because there's not two of them, then what? Well, I guess I can check. So in theory, it's possible that It doesn't find them. So, okay, so without worrying about the edge cases, this should be something like return the smaller or the bigger of max possible minus the low remainder 1, or max possible minus the low remainder 2a minus low remainder 2b. Okay, if this is, I guess if they stick at infinity, then this is going to be a very big negative number, so I guess I don't have to worry. I guess a very, very negative number is not going to be the maximum, but yeah, this is fine. Okay, and then the other one is going to be low remainder 2. I guess this is very similar in logic. Also difficult in logic. There's probably a way to rewrite this without there's probably a way to write this without having to just copy this logic almost exactly. So this is case 2, values less than low remainder 2, low remainder 2 is equal to this value. Case 1, value is smaller than low remainder 1b, then low remainder 1a, low remainder 1b is equal to value comma low remainder 1a, value smaller than low remainder 1a, else low remainder 1a comma value. I think that's fine. Turn max of max possible minus low remainder 2, or max possible minus low remainder 1a minus low remainder 1b. Okay. False. Name value is not defined. Ooh. Let's say a for loop here. Every value in nums and similarly for every value in nums here. How many values to unpack? Guess you can't actually do this statement, huh? Interesting. Can you not do that? Too many values in fact. Okay, well, worth a shot, I guess. I guess, yeah. I guess you can't really have a tuple like this unless you actually store a tuple. Yeah, okay. That's fine. Value is less than 2a. And do this. Else. Low remainder 2a, low remainder 2b is equal to that. Okay. Guess that's probably easier to read anyways. Value is less than low remainder 2 remainder 1a. Else lower remainder 1a, lower remainder 1b is equal to that. Yeah, misspelled it. If that's the only misspelling, then that's probably above average for my error rate. That is not the only misspelling. Low remainder 1. What am I missing here? Low remainder 2a. Oh, declared it twice there. Okay. Sweet, 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 sweet. Okay. Definitely this sort of math problem is right in my wheelhouse. Okay. So, summary can look at above example for logic, but basically to get to the nearest divisible by 3 sum, break down to 3 cases where the sum is divisible by 3. I guess this is case A. Sum divisible by 3. It's going to be trivial. Return sum. Sum divisible by, or sum mod 3 is remainder has 1. So either remove smallest remainder 1 a value in from sum. So like remainder 1 might be 1 or 4 or 7, or 2 smallest remainder 2 values from sum. So 2 2's would combine to be a 4, which is the remainder 1. So either one of those is going to be getting it to something that's divisible by 3. Sum mod 3 equals 2. So because remainder 2, either remove smallest remainder 2 value from sum, or 2 smallest remainder 1 values from sum. And then use for loop over all values, keeping track of the appropriate low values, and return the sum minus the, or return the bigger sum from the above calculations. Couldn't find a faster way to keep track of the low values besides using if and if else statements, a bunch of nested if else statements. So yeah, for every value, find the remainder. If the remainder is remainder 1, see if it's smaller than the current track, small remainder 1. If the value is remainder 2, keep track of the smallest, so second smallest remainder 2 values, assuming this is the sum originally, the maximum possible sum is remainder 1, then do similar logic for the other one. Time complexity, this can be O of n to iterate over every value in sum. finding the max, and then finding the appropriate small remainder values. Constant work is done at each iteration. And then space complexity, this is going to be O of 1, since no extra space is needed. Just a bunch of constant variables.